Okay, so that's awesome. Yeah. So hello everybody. Today I want to share my thoughts and insights from the recent weeks when I made a first step over upgrading Hanami from 1 into Hanami 2. The first step was about updating persistence layer. Previously we used, or maybe currently we use in our projects hanami-model and hanami 1, and the transition to hanami 2 requires us to switch into the ROM persistence layer directly, ROM RM directly. I'm Sebastian Wilkosz. I'm working for Ascenda. And the why. First of all, as I said, hanami-model is using old versions of libraries. First of all, it's ROM 3. This is my part, while ROM 6 is behind the corner. And we cannot just upgrade because the versions are locked. And if we would like to just upgrade ROM version after the version, we would probably need to rewrite the gem, or at least hack it in various places, which is not less work than just get rid of it and use ROM 6 directly. And other old libraries prevent us from upgrading to Ruby 3, which comes with a lot of performance improvements, security updates. Yeah, just a lot of crazy stuff that we would like to have in our projects as soon as possible, but we are unable to do so. So this is also why we want to switch into Hanami 2, which requires Ruby 3 at least. So strategy as I took was first to update all the gems as much as possible, and then switch from hanami-model to ROM 5 configuration, fix all filing tests, then go through the main features and figure out if there are any overlooks or insights. A big shout out to Hugh, who already did that for Guardhouse and in the past. And I had his PR to be inspired on, and it helped a lot. So what could possibly go wrong? It seems very straightforward. I had the PR, I had the strategy, so yeah, nothing, right? My small PR has like over 300 files changed, and fortunately most of those changes are pretty simple, straightforward, and not like renaming the constants and just updating every single migration file with one line. And this is why there are like tons of files changed here. But surprisingly, if I will compare that all along, it was simpler than I thought. So not such a big and crazy stuff. But about the update gems, we have the practice to always update gems as much as possible in our company. So it is usually not a big deal. We have a lot of already newest versions. So the only thing that cried to me was the dry container update. I needed to lock it at 0.8 to end debugging. That was pretty hard. But after this, I could just jump into the replacement of the configuration, which was not too much. And the thing is that I did not know advanced ROM configuration at that point. So the proper plugins configuration, that was pretty troublesome to figure out. I also forgot to set up the time zone for SQL. And this was a bit of delay in a lot of their tests failing randomly because of time zones, and I had no clear idea how to fix it quickly. But fortunately, after we figured that out, it was just a one line of code added to the configuration, and that was awesome. And also, I need to add a custom types definition, which required for me to dig into understanding how dry types work under the hood, how to compose custom types, and things like that. Some activities, some types I wrote will not be necessary because there are better approaches for this. But just to make things working, I just added them. It was to not blocked anymore. But in the next iteration, I will just go through it and try to leverage the built-in ROM features better. So this is the example of the hash coercions, the custom type I wrote, and it was written to make sure that I deeply symbolize hashes, because hanami-model read JSON-B columns from the table and always returned symbolized hashes, which was very cohesive with the rest of the attributes. But when I switched to ROM, it appeared that the JSON-B columns were stringified. And even if I actually symbolized them for the nil values in the columns, the hash transformation failed. And also, if we had nested values, nested keys in the JSON-B columns, which we have in some metadata, in those cases, ROM returned the SQL version of the hash object, and that did not play with deep symbolization. So it was kind of tricky to figure all that out. So there are two things here. One is for transforming hash to JSON-B, and yeah, here I also needed to check if the instance is the JSON-B hash that comes from the SQL Postgres extension. But overall, this probably won't be needed at all. This is kind of a hack that I made to make things working. But if you will update your projects, you will have all this code available. So, but I also reached out to the community, and a lot of people helped me to figure out better solutions. I hope it will work, and then I will get rid of those custom types that does not look like pretty well. Yeah, the usage is like this. So I have those two coercions. When I read the data from the system, I symbolize hash using my custom coercion that deeply symbolizes everything. And for writing, I get the hash and transform it to the JSON-B format. But the usage is pretty simple because I only have types, JSON, be constant, and I don't care about all those strict nil, coercions, hash to JSON-B, and what to do on read, and so on. It just took time to figure all that out. And then, having that, I was able to update migrations. And the tricky part was that ROM works with the DB migrate column, but we used DB migrations column. Folder. ROM works with the DB migrate folder, while we worked before with the migrations folder, and that did not play well. Again, the error that came from that was pretty not clear. But pretty simple. However, moving all that migrations to a separate folder, you can imagine how much files already had been added to the PR changes. And this is why when any of you will review such PRs in your services, you probably will be better to review commit by commit instead of just trying to do the review of the whole PR at once, especially because the GitHub does not like such big pull requests and kind of browser freezes all the time. So then in the migrations, we have the not too much changes. We had like constant renaming and some minor syntax changes. Like for example, we had before the primary key with UID type, but after that we needed to use the column ID for the UID types and set the default function to SQL generation. What I found good about our migration is that we did not use migrations to seed data too much. We only used it to actually modify the schema of the database structure. And this is something I faced in the past a lot with various Rails projects, where model classes leaked into the migrations. So in case of old projects, a lot of various hacks were required to actually make migrations working and backward compatible if something had been removed from the list of defined models, for example, or the model had been renamed, the table had been renamed, things like that. But in our case, it was not a problem at all. It just went very smoothly. If we ever needed to seed data, we just used the raw SQL queries, and that helped a lot in this case. So hooray! However, there were some caveats, and the rake tasks stopped working. Again, like Hanami 1 and Hanami 2 also, or Hanami 2.1 also will come with full set of rake tasks for migration support. But when I switched to ROM, I wanted to work directly with the ROM rake tasks. They did not work for some reason, which I did not figure out yet. So based on what Gerhard's team did, I actually copied the definition of the DB rake tasks. But now when I know a bit more, I think it should not be necessary. So this code, this is just a rake task copied from the ROM database that I put into our project to make things working, but I think I have idea to just get rid of it and use the built-in ROM solutions, because ROM actually comes with all the necessary rake tasks to manage migrations, manage schema, create, or maybe not create, but roll out, reset tables, reset database, run migrations, and also perform the generations for the generators for the migration files. So that should be just built in. Then we started reaching out to the bigger differences. Hanami one worked with repositories and entities at most, like at at first, but ROM is oriented around relations, and the relation is the key of the ROM, the heart of ROM. And to be honest, with except relations, you don't need anything. Like you can work with relations and don't care about repositories or entities at all. But of course, those abstractions help to keep things clean and well maintained in the project. But I needed to add a lot of migration relations. I need to add a lot of relations files as a next step for all my tables, which was not too much of work, especially for Vim users. And this should be pretty fast with macros, leveraging macros and so on. But the key thing here is to actually to set the name of the table used in the relation, because without that it tries to get the namespace, the persistence relations namespace, and add it to the table name that will be used, because the just infer true just tries to figure out everything out of the box. And this is a little bit of the overhead maybe, but it's just one line of code. The auto-struct true, I'm not sure, but probably I can do the base relation class and just put it there. This is something I need to test yet. With this, I need to just do small updates to the repos. But and while the definition was not really changed too much, we needed to do some minor changes to the syntax of the querying. And for example, before relation plug method accepted the arrays, while after the upgrade, it accepts the list of arguments. And big shoutouts to Huming for mentioning that. And also, there are some changes within the type variables that like int is changed to integer, str to string, and so on, and few little caveats like that needed to be manually adjusted. And with this, we came to the tests update. In tests, as you can imagine, there was a lot of small changes as well, like repository name updates or some minor queries adjustments. But most of all, mostly it is just repeatable small changes, but in a tons of files. Again, I love Vim for allowing making such changes quickly within the project. So free advertise. Then we added the entities namespace to the projects. We are slowly moving into the entities, which did not require too much attention. Before, we didn't need to like define any attributes in the entities, and now we also don't need to. But we decided to add the entities namespace because it will help us in the future and improves the overall maintainability of the projects, of the project, reduces the risk of naming collision and things like that. It is optional change, which also added tons of code changes to the PR, and maybe, just maybe, I will be able to extract it. We'll see, to a separate PR to make the overall review process easier. So this is the just updating, but in a lot of cases. How we can improve on it? My suggestion is, if you use entities in the project, consider wrapping them in the entities namespace before the actual ROM upgrade or the Hanami upgrade. Merge it, test it, and this will probably help a lot, because this is a huge update, and minimizing the files that needs to be affected definitely will help. Especially that a lot of entities have been used in the tests, and it would be awesome to just not have those entity renaming, like adding entities prefix to the each constant in the each usage of the spec. That is the main problem. So with this, still a lot of tests were failing, and we needed to switch our fabrication gem to the ROM factory, because ROM factory works with relations by default, and fabrication is mostly focused around entities. And if we want to do this, we would need to define manually all the attributes within the entities. And because we did this change, we were able to just use in relations infer schema true, and all works out of the box, or mostly. Those gems are pretty similar in usage, so there were, again, not big deal to change all that. However, just tons of minor changes. Like you can imagine, just adding define all here, adding the f variable to the block, and things like that. So if you can do it quickly, probably you should use some fancy tooling for that. Yeah. Again, in the tests files, this is the factory definition, and inside of tests, again, tons of small little changes. That is probably a pain in the bottom to review, but yeah, life. So is it all? Unfortunately, no. There were some other caveats, and all that what I shown were simple changes, repeatable changes. When I applied, application had been running, had started, and most of tests actually started to pass. So that was very good. I had like last 100 of tests that were failing for various cases, and they were mostly related to JSON-B columns, like this deeply symbolized JSON-B columns issue, that I spent some time to figure that out, and but I already talked about it, so I will not go into it in the big details. But also the multi-insert, we used some, except that just creating, updating records or removing records, we also have some actions like copying full tables, for example, for reporting. We also do the multi-insert in some parts of the system, and this stuff do not leverage the whole ROM type transformation out of the box these change sets or entities, and it was like multi-insert, for example, works with the plain hashes, and probably there are ways to improve it, but this just started to fail because it worked differently than the actual how to say it, the actual inserting using the repositories. So that was a big caveat to figure that out. So what else? Yeah, this is yeah. So the next part was the non-existing attributes. hanami-model ignored extra attributes that are passed to the repository, for example, when you create, and just creates a record without this extra thing. But ROM 5 is a bit more strict, and it raises an error when extra attribute is passed. And we actually had just leftover in the test. It was not intentional, but it was just a leftover where very like invalid hash, probably copy paste issue, where the extra attribute had been passed to the during the factory creation, and this one started to failing, and this is why I actually know about it. Without this, I would be not aware of this issue. So if your application actually relies on such thing, you probably want to have it tested and have a solution for it. Yeah, just wanted to point it out because without this random failure, I will just not know about it. So next thing is the order of columns. When we use the copy table with the data set, when we copy all the table, it appears that previously columns were listed in different order, and the target needs to be defined in the same way. So it was not expected that this kind of things matters, but actually it does. And I needed to explicitly specify the correct order of columns that were expected to actually copy the one table to another. And also the similar thing will happen for CSV reports. We started to get CSV files with wrong order of columns, and that was like, what the hell is happening? But it was exactly the same issue. We just relied on some data set to hash definition, and we just never ordered the column properly, which actually started some stuff to fail or work unexpectedly. And then there are, oh yeah, just this is I forgot about it. Without this, our application did not run yet because dry validation in the old version which we used was a merged functionality of dry schema and dry validation, and after the upgrade it was split apart into two separate gems. And there were some syntax and feature changes. So for example, an upgraded dry validation accepts symbols instead of strings in the like require or optional fields. But the old validation worked with strings, and this just did not allow to boot the application because it was a syntax error. So needed to upgrade all our schemas, all our in the system, and this again added tons of files to the PR that needs to be checked. So it's not the best, but we were unable to upgrade dry validation in the past. And if you want, like other changes that are related, is that some predicate logic, predicate definition have been changed. There are rules that are parts of the dry validation contract, but the schemas are in the other schema. And for example, nested contracts are not supported, and I needed to hack it to actually ensure backward compatibility. Because we heavily use schemas for validating our settings for various clients, various tenants, we have sometimes pretty complicated validation logic for like conditional nested structures, or using different contracts depending on what other attribute value contains. And this kind of advanced behavior was not trivial to endure, depending on how it is on your side. Yeah, just make sure you know about it, or reach out to me. I will be able to maybe add some insights into the update. And finally, the DB enums. I hope it is finally. We use DB enums in the tables on the Postgres level defined DB enums, enum types of data. And in the past, I don't like enums because this is Postgres level thing, but it contains some logic, some types, and it's not. It's easy to forget about testing for DB level enums. The other thing is that Hanami-1 allowed to pass integer into the database for enum types, and in after the upgrade, actually ROM cries about it and returns error, and that forcing the schemas that are passed to be strings. And again, we had only one place in one test when we just created an object to the unit test, and probably someone just did not want to check the actual value, just passed the integer there, and this test had been failing, and this is why I got the information that this is a thing. If your application relies on passing integers and be transformed on the DB level to the string kind of representation, it will be saved as it will be saved as integer, but yeah, just to be readable. You may encounter some troubles, and hopefully you have this kind of things tested as well. So my question to all of you is, if we do want DB level enums to be actually left in our code base, or maybe there is a chance that we want to get rid of it and rely on it less. So maybe with the introduction of the data warehouse, we will be able to just work more on the Ruby level type definitions instead of working with Postgres enums, but we'll see. This is an open question for all of you to write back to me on the channel later. I'm happy to discuss more about it. So what are my learnings? First, know how to test well and what to test. So test the edge cases. I found that a lot of tests we had were just written for successful or one failure example, like use case, but in terms of accepting ranges of data. Not always it's tested for edge cases, the border values and things like that. So this is where we start, where I started to see a lot of holes in the test coverage in our system. Also, just remember that the test coverage report is only a high-level guide. We are already made some improvements enabling the branch test coverage in Loyalty Engine, Points Bank, I guess, and also the reporting part. But yeah, just this is just a reference. It should not be a first citizen of how you know that your application is well tested, or your class or your method is well tested. And the next step for reporting is to prevent to improve this simple COF configuration to actually prevent the downgrading of the test coverage. So you will be able to push a PR or open a PR only if your test coverage is remained at the same level or higher than it was before, because otherwise the build will fail. And it will kind of force us to slowly over time improve our test coverage. And even if you will have some code that does not really require testing, developers will be encouraged to just find at least one place where something is not well tested and just add a test for that. I hope this will be sometime useful. It's experimental in reporting, but wanted to share it with you. And also, I know I found that we rely in reporting heavily on data. This is data-based application, but we only validate the table columns types. For example, if I have ID, I validate that this is a type of UUID, or I validate the metadata, and I know that, and I ensure that this is the JSON-B column. But for nested data schemas, often there are overlooks. We don't pay enough attention to test the nested JSON-B columns, and this is somewhat I would love to improve on in the near future. So next learning for me is to ask for help early. The great team is priceless. I got tons of help from all of you, from Hugh, from Huming, but just a lot of people jumped in to my questions and helped to me. But also, what I did is I published some questions also on the community forums, and I found that tons of great Ruby developers, even core team members of Hanami, of ROM, jumped in and helped me solving the problems even in a better way that we all were able to figure out. And this is a big one, to not be afraid to ask for help on the public channels. Other people that will came through this problem in the future will also probably need the same knowledge. So the next thing is that to leverage more the repository pattern in ROM. There is a saying to not leak the adapter information into repositories, that relations are adapter specific and repositories should not be. And we sometimes don't remember about it, and we leak some information from some adapter information to repositories, which actually made me a little bit harder to work with repositories updates during this change. Also, the second thing I wanted to point out is that we use too little repositories at the moment, maybe because of how the Hanami one had been structured. But I see the coupling for repositories with the actual entities or relations we have. But some methods of repositories do not return entities, but rather return some hashes, because we need a different set of data. And the truth is that for those cases, when we join multiple tables and return custom data structures, they should work with different entities with different data structures, so they are different classes. They should be separate repositories, and this was a big thing for me to understand. So one learning is that repositories are domain level and relations are a database level. They don't need to be mapped one-to-one. We can have much more repositories than we have relations. Okay. Leverage dependency injection. We already do it a lot. And when we have the dry system integration with site work, it will be even like overpowered. But in a lot of places, I found that we don't use this dependency injection. We just instantiate the dependencies in different ways within the methods, and that forces us to mock a lot of stuff in tests in the very explicit way, which causes some troubles in occasion of such upgrades. Like when heavily mocked test actually fails, it's a pain to refactor it and make it working. Of course, it is possible, but it's just more effort than if you would use dependency injection more. So this brings us to the next steps. When I will release this ROM 5 upgrade, the next part would be to upgrade Ruby to 3.x and then update all gems once again that actually cannot be upgraded because we use older version of Ruby. And then we will be able to upgrade the Hanami as the next step. Finally, after the upgrade, I will look more into architectural topics, and we'll try to organize our application better to leverage slices and make it more clear in the whole code base. So remember, now after this, I am another person that can put some insights into the Hanami upgrade. If you will encounter any blockers or any problems, feel free to reach out. I'm gladly to help. Thank you. Do you have any questions? That was a long one. Let me open the chat. Oh, Long wrote to me that the plug change is a Ruby 3 upgrade. But I don't have Ruby 3 yet, so I'm not sure if I actually understand it correctly. I still use the old Ruby. I did not upgrade the Ruby. But it may be that ROM, like forces it, or SQL. I'm not sure if this is a SQL thing. Probably this is a SQL thing, that this syntax had been changed because of Ruby. So to make it future compatible, not backward compatible. So this is probably fine, and maybe this is a preparation for, as you said. ROM not really stringify keys, but that Postgres did. So correct me if I'm wrong, but I understand if I understand this question correctly. But ROM actually symbolizes the attributes. So the key metadata is symbol, but then in the as a value is the SQL Postgres hash, JSONB hash, and this is not symbolized correctly, and you end up with the stringified keys from the meta JSON B column. There are fixes for it, like not even fixes, like this behavior can be solved using the native ROM features, but I just did not know how, so I wrote the custom type mapping, but I probably will get rid of them very soon.